Good evening, everybody, and welcome to the Museum of Science. I'm Lisa Monrose, producer from the museum's Lectures and Special Programs Department, and I'm honored to host tonight's speaker, the world-renowned theoretical physicist Michio Kaku. Dr. Kaku is the co-creator of string field theory, a best-selling author, and host of the popular radio programs Science Fantastic and Explorations of Science, which reach 130 cities across the country, including Boston. If you'd like to know which radio station in Boston, just go to his website and you can tune in. Dr. Kaku currently holds the Henry Seamat Chair and Professorship in Theoretical Physics at the City College of New York, where he has taught for more than 25 years. His books include Beyond Einstein, Hyperspace, and Parallel Worlds. His newest book, Physics of the Impossible, draws on the world of science fiction to explore whether invisibility, telekinesis, force fields, time travel, and other so-called impossibilities might one day become a reality. Physics of the Impossible has been on the New York Times bestseller list for 5 weeks running now, is the #1 science book selling in the country, and number 12 of all books selling in the country. So congratulations, Dr. Kaku. That's fantastic. New York Magazine recently ran a contest to find out who are the 100 smartest people in New York City. Dr. Kaku made the list. So it's official. We are hosting one of the smartest people around. So please join me in welcoming Michio Kaku.
Wow. Wow. After such a great introduction, I can't wait to hear the speaker myself. And I have a confession to make. It's true that New York Magazine voted me as one of the 100 smartest people in New York. However, in all fairness, I have to point out that Madonna also made that same list. Very smart woman. Now today, I'm going to take you on a guided tour through the cutting edge of physics as we begin to develop in the laboratory prototypes for invisibility, teleportation, perhaps even starships, telepathy. You'll see this on some video clips that I did for BBC television. I hosted a series for BBC called Visions of the Future, which will eventually be aired in the United States sometime next year. So we are talking about the future. These technologies are impossible today. However, when making predictions, it's always a little bit dangerous. Let me now quote from that great philosopher of the Western world, Yogi Berra. Yogi Berra once said, quote, "Prediction is awfully hard to do, especially if it's about the future." Well, we physicists invented the laser, radar, radio, television, the transistor. We helped to create the internet. We wrote the World Wide Web. But when we helped to create the internet, one physicist made a prediction, and that is that the internet will become a forum of high culture, high art, and high fashion. Well, today we know that 5% of the internet is pornography. But that's because teenage boys log on to the internet. Just wait till the grandmas and grandpas log on to the internet. Then 50% of the internet will be pornography. Now, before I begin, you may say to yourself, well, maybe you physicists know too much for your own good. Well, let me tell you a story. 200 years ago in France, we had the great French Revolution, and many people of the aristocracy lost their heads to the guillotine. One day, there were 3 men about to lose their head. There was a priest, there was a lawyer, and a theoretical physicist, just like me, about to have our heads chopped off. Well, they put the priest's head on the chopping block, and they asked him, "Do you have any last words before we cut your aristocratic head off?" And the priest said, "Yes." He said, God from above shall set me free." Well, they raised the blade. Everyone was looking at the blade. The blade came down, swish, and it stopped right before it hit the neck of the priest. Well, they'd never seen that before. They had slaughtered thousands of people. The first time the blade stopped right before it hit the neck of a victim. The crowd said, "Let the priest go. God has spoken." And now let's see about that lawyer. Well, now the bloodlust was starting. Yes, the lawyer, the lawyer. They put his head on the chopping block and they asked him, "Do you have any last words?" And the lawyer says, "Well, I don't know too much about God, but maybe the spirit of justice shall set me free." Well, they raised the blade. The blade came down, swoosh, and it stopped right before it hit the neck of the lawyer. This time there was dancing in the streets of Paris. People were saying, "God has spoken. Justice has spoken." And now let's see about that theoretical physicist. Well, they put the physicist's head on the chopping block, and they asked him, "Do you have any last words before we cut your head off?" And the physicist thought for a while, and he said, Yeah, I got some last words. And he said, "You know, I don't know too much about God, and I know even less about the law, but I do know one thing. If you look up, you'll see that the rope is stuck on the pulley." And then he said, "If you remove the rope, the blade should come down real good." Big mistake. Big mistake. Well, the rope came down, the blade came down, and the poor physicist's head came down. And the moral is, sometimes you have to know when to keep your mouth shut. Okay? But nonetheless, we physicists have prototypes of these fantastic technologies that you really only see on Star Trek or Star Wars. Now, there's a long track record of people making predictions that certain things are impossible only to have them become possible. This is Lord Kelvin. The Kelvin scale is named after him. He's buried right next to Isaac Newton in Westminster Abbey. And he predicted that airplanes would never exist. He said that X-rays were a hoax, no such thing as X-rays. Radio, what possible use could radio have? The Earth is only a few million years old. All these predictions, wrong. Why? Because we didn't understand the basic laws of physics. The nuclear force, for example, wasn't discovered during the time of Lord Kelvin. This is now Robert Goddard, the father of modern rocketry. However, the New York Times denounced him in an op-ed article, saying that his work is worthless because rockets cannot move in outer space because there's no air to push against in outer space. Well, I think the only hot air was the New York Times editorial section. This is the man here who is the father of modern rocketry, denounced by the New York Times. And Arthur C. Clarke had 3 laws of impossibility. He was sick and tired of people saying that certain things were impossible, so he created 3 laws of impossibility. The most important is the third. The third one that we'll talk about today. Quote, "Any sufficiently advanced technology is indistinguishable from magic." That's the theme of today's talk. So let's talk about classes of impossibility. Class 1 impossibilities are impossible today, but possible within a few years, decades, or maybe a century. And believe it or not, most of what you see on the silver screen, Hollywood movies, are possible. They are class 1 impossibilities. Ray guns, force fields, invisibility, teleportation, starships, telepathy, antimatter engines. Class 2 impossibilities will take centuries to millennia. They are at the very edge of what we know about physics, including time machines. And class 3 impossibilities are simply downright impossible. I get calls from the Wall Street Journal saying that some enterprising inventor has conned millions of dollars from investors claiming to have perfected a perpetual motion machine. So I quote to the Wall Street Journal the immortal words of that other great philosopher of the Western world, P.T. Barnum. P.T. Barnum said, quote, "There's a sucker born every minute." So let's talk about impossibilities. At the University of New York, at CUNY, I teach a course in optics. And I tell my students, until recently, Invisibility is impossible. Light cannot wrap around an object, reform at the other end, just like water going around a boulder. Water can do it. Light cannot. Well, 2 years ago, I was proven wrong, as well as every single physics textbook in the world. Let's have the first video. We're now going to go to Duke University in North Carolina 2 years ago, where history was made. As we saw here, is to go from microwave to visible light, and that was done 6 months ago at Caltech, the University of Karlsruhe in Germany, and also the Ames Laboratory in Iowa. At a microscopic level, using very small particles of light, they bent ordinary light, red light and blue-green laser light, in a way consistent with invisibility. So then the next question is, Harry Potter, watch out, is an invisibility cloak possible? Well, there are problems. First of all, as you see here, Harry Potter has to look out. He has to have at least 2 holes in the invisibility cloak to look out. Therefore, when you look at Harry Potter, either you see a floating head or 2 floating eyeballs. So that's a problem. Second of all, we have to do this with a cloak, and that may take many, many decades. We think a cylinder. A cylinder is perhaps the easiest way to reproduce invisibility. You put a cylinder around Harry Potter. Light would then hit the cylinder, wrap around the cylinder. This is how it's done with metamaterials at Duke University, and this is how we think it'll be done with visible light. Light wraps around an object, reforms at the other side, so that downstream you don't know there's an object upstream. So once again, we have not yet done it for a large object. We've done it for a microscopic object. But now, nobody is a disbeliever. The Pentagon is funding these studies. Laboratories around the world, everybody is jumping into the game. We think we will have full invisibility in the coming decades. And yet, just 2 years ago, it was thought to be totally impossible. Now let's talk about another impossible technology. The transporter. First of all, why did Gene Roddenberry invent the transporter for Star Trek? Well, you see, the Star Trek pilots were going over budget. Paramount Studios was very unhappy. Paramount Studios said all this landing on a planet, taking off, landing, taking off was costing too much money. There's got to be a simpler way to land on a planet. And then Gene Roddenberry says, okay, we'll simply beam them on the planet. That's the origin of the transporter. Budget cuts at Paramount Studios, according to his memoirs. Now, let's talk about real quantum teleportation. We have now teleported particles of light, individual atoms, and in the next video, again taken from this BBC special that will be aired in the United States next year, we're now going to go to Vienna. In the next video, we're going to go to Vienna, to the university there, and actually see the people and the instruments that created the world's first teleportation. So let's have the next video. So as you see in the video, at the present time, we can teleport particles of light called photons. The next trip will be to the space shuttle. We will teleport from the Earth into outer space to the space shuttle. After 2020, when we go to the moon, we'll be teleporting to the moon. We're asking permission for NASA to do these experiments now. Atoms have been teleported. Beryllium atoms, cesium atoms, both types of atoms have been teleported. And as was mentioned, we hope to teleport molecules within a decade, water, carbon dioxide. After that, maybe even DNA. Maybe even genes could be teleported, maybe a virus. But a human, well, Captain Kirk consists of 50 trillion cells. That's a lot of cells to teleport. But one day, when we teleport Captain Kirk, you will see him dissolve. You will see him die. And a copy will emerge over there who says he's Captain Kirk. Now, wait a minute. You just saw him die. Who is this imposter over there? He has the same memories, the same genes, the same neural circuits, the same personality quirks as the original one, and he's still trying to sell Priceline for you. I mean, what's happening here? Where is the soul in all of this? Well, the answer is we don't really know. This is one of the cutting-edge questions. But like I said before, this exists. Proof of principle of invisibility has been demonstrated. Proof of principle of teleportation has been demonstrated. But it may take decades before it reaches our living room. Now let's talk about ray guns and Death Stars. When Star Wars first came out, people were saying, wow, what a movie. But the critics hated the Death Star. They said that a planet buster that can vaporize an entire planet cannot exist. Well, they were wrong. It turns out that there is no upper limit to the power you can put on a hydrogen bomb or even a laser beam. And for that matter, there are naturally occurring black holes that shoot out beams of gamma radiation through the North Pole and the South Pole, shown here. These gamma ray bursters are like rifles. They shoot enormous blasts of radiation for thousands of light years. They can be seen throughout the entire universe. I repeat, when a gamma ray burster goes off, it creates a black hole. They are visible throughout the entire universe. And last month, we found one of them pointed at us. This is the bad news. WR104 is a double star system shown here. The North Pole is staring at you in the face, and if it blows, it will shoot a beam through the North Pole and perhaps hit the Earth. It is 8,000 light years away, within the rifle range of a gamma ray burster. It is capable of incinerating the entire planet. Here is a time-lapse picture of it taken by telescopes. You see that we are in the North Pole, right at the North Pole of WR104. We're monitoring it. Maybe it already exploded 8,000 years ago, and its light is just reaching us today. Maybe you're doing your laundry tomorrow. You look up, and all of a sudden, you are toast. Literally toast. That's the bad news. The good news is we've checked the alignment of WR104. It is slightly misaligned from the Earth by a few degrees. The beam may actually miss us, or it could be a dud. We know very little about gamma ray bursters. The point is that you can, in fact, have radiation levels so intense that you can fry an entire planet. And here's one just discovered a month ago that is pointed right at us. Now let's talk about mind reading and telepathy. We've all seen these magic shows on TV. We've seen these magic shows in Las Vegas dazzling us with all sorts of mind-reading capabilities. Now let's talk about the real thing. This is BrainGate, which was an experiment done at Brown University. This gentleman here had a stroke. And as a consequence of the stroke, he is paralyzed. Many of his muscles don't function at all. He cannot communicate with the outside world. He's like a vegetable almost. So what they did was they put a chip shown on the upper right. It's much smaller than a penny. It was inserted in his brain on the lower left. On the lower left, you can see exactly the place where this chip was inserted. The chip was then connected to a laptop computer. After about 3 hours or so, he got the knack of it. By thinking, he was able to move the cursor on the screen. Now, he can do crossword puzzles. He can surf the web. He can answer your emails. He can play video games. And he is paralyzed. And he does it by thinking alone. By pure thought, he's able to control a computer. And from a computer, you can control God knows what else. You can drive a car, guide satellites, do mathematics, do crossword puzzles, purely by the power of thought. Here he is, shown paralyzed with this object sitting on top of his brain. In the future, that object will be very tiny, even microscopic. You wouldn't even be able to see it, and you'll be able to surf the web just by thinking about it. The next time you take a final exam and you want to know what the answers are, in the future, you might be able to scan the web just by thinking about it. Also, it's possible to read some of these thoughts. When you tell the truth, only a teeny-weeny part of the brain lights up on an MRI scan. When you tell a lie, that part of the brain lights up like a Christmas tree. The reason is, when you tell a lie, first you have to know the truth. Then you have to know the cover-up. And then you have to know the consequences of the cover-up. That's a lot of brain power, okay? So this is already possible today. It has all sorts of civil liberties, societal consequences of this. This is going to go to court this year. A man was denied an insurance claim. The insurance company said that he burned down his own house. The man got so outraged that he took this insurance company to court, and he is willing to have his own brain scanned in court to test the validity of this technology. This is coming real fast. This is your contact lens of the future. It has a chip in it. You'll be able to surf the web simply by looking out your contact lens. Computers are getting smaller and smaller and smaller all the time. In fact, on Star Trek, they have the tricorder by which they can peer inside your body. In the future, we will have an aspirin pill such that there's a computer inside, a chip inside the aspirin pill, and a TV camera. This already exists. You swallow the aspirin pill. It goes down to your stomach and takes photographs and sends the information to a PC as it goes down your stomach into your intestines. This eliminates the need for the dreaded C word that every male person fears, colonoscopy. Also, this gives new meaning for the expression, Intel inside. These chips, by the way, are so tiny they're being placed in toys right now. That's creating a problem for the English language, a contradiction in terms called smart Barbie dolls. Another contradiction in terms is Microsoft works. That is also a contradiction in terms. Also, with these contact lenses, they can recognize people's faces. We've already tested this on pre-programmed faces. How many times have you been at a conference like this and bumped into somebody that you met a year ago, and you say to yourself, who is this person? I remember it's Jim, John, Jake. Who is this person? In the future, your contact lenses will say, it's Jim, stupid. Remember? You met him last year. You want to see his entire biography in the lens of your contact lenses? And let's say afterwards you're at a cocktail party. You're looking for a job. You don't know who the important people are. You don't know who the heavy hitters are. In the future, you will know exactly who to suck up to at any cocktail party. Now let's talk about starships. Wouldn't it be great if one day we can go to visit the stars? Many people say that flying saucers are impossible because the distances are so great that we will never go to the stars. And yet NASA is already setting up study groups looking for the possibility of building a starship maybe by the end of the century. I'm one of the people reviewing proposals for NASA, and NASA is serious about looking for prototypes to visit the nearby stars. Here are the finalists. One possibility is a solar sail. If you saw Star Wars, I think episode 2, the bad guy escapes in a sail that is inflated by starlight or laser beams. You could have a bank of laser beams on the moon, shooting a beam to the sail, inflating the sail, and you literally coast on light. This is a very serious proposal. Of course, if you sail to a nearby star, one problem is, how do you come back? Coming back is a problem. Here is 2001, talking about robotic probes. How many people here in this room have seen 2001? Raise your hand. How many people here have understood 2001? Raise your hand. Let me explain. Stanley Kubrick, in the first 10 minutes of 2001, explained it by having interviews with scientists. Scientists said, think of a virus. How does a virus take over a human body? A virus is a cell. A tiny particle which lands on a cell. It then hijacks the cell, creates copies of itself. Thousands of other virus particles will then go out. They land on cells. So starting from one virus, you have 1,000. Then 1,000 times 1,000. Then 1,000 times 1,000 times 1,000. And after 2 weeks, you start to sneeze. You have a cold. That's the way to colonize the universe. This probe here is a robot, like a virus. It lands on the moon. Moons are very stable, no erosion, no rain, no rust. And it creates a factory. A factory. You saw that scene in 2001 where you saw millions of these objects floating around Jupiter? That's what it is. It's a factory. It's a factory that makes copies of itself which land on other moons. Then they make copies of themselves. And it goes on and on and on. From one, you have 1,000, then 1,000,000, then 1,000,000,000. And pretty soon you colonize the Milky Way galaxy. But then, in a fit of fury, Kubrick cut the first 10 minutes of his own film, and the film became super mystical. This is, in fact, the most realistic encounter with extraterrestrial intelligence. We cannot rule it out, but maybe, just maybe, there is a robot probe left on our moon by a passing civilization. Now, my favorite is fusion engines, ramjet fusion. They're like an ice cream cone that suck up hydrogen in the forward direction. They run forever. There's no fuel problem because hydrogen gas is throughout the universe. So here is a starship that requires no refueling whatsoever and runs forever. Now let's say a few things about robots and artificial intelligence. One day will we have robots that are so smart, they'll put us in zoos, they'll put us behind bars, they'll throw peanuts at us and make us dance, just like we make bears dance behind bars. Well, let's think about this. In the next video, we're now going to go to Tokyo. Japan produces some of the most advanced, realistic robots in the world, and let's find out how smart are robots. So let's have the next video where we're now going to go to Tokyo and see. The ask is, how advanced are our robots? Are they as smart as a dog? Are they as smart as a cat? How smart are our robots? Well, let me tell you the answer. Our most advanced robots, after almost 100 years of tinkering with robots, our most advanced robot has the collective intelligence of a cockroach, a retarded cockroach, a stupid, lobotomized, retarded cockroach. If you see a cockroach on your table in your kitchen, you raise your hand. The cockroach immediately recognizes your hand and says, danger, 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 and runs into the corners. I know. I live in New York. But on Mars, our most advanced robot is on Mars. It's called the Mars rover. If a Martian were to raise his tentacle to the Mars rover, which can barely recognize a rock, would say, is that a cow? No, not a cow. 6 hours later, is that a giraffe? No, not a giraffe. Meanwhile, the Martian would have gone whack with the hand. So you see that our most advanced robots are not very intelligent. So what's the problem? What's the problem with having these kinds of robots? Well, first of all, why is Japan building these robots? Let me tell you a secret. Most people don't know this. The reason why Japan is building the most advanced robots in the world is these are the future robot nurses. Japan's population is aging the fastest in the world. It is the fastest aging population in the world. Japanese women live the longest of any ethnic group in the earth. So these are the future nurses because immigration to Japan is almost zero. Something's got to give. And so these are the future nurses of the world. So the question is, well, can we really make these robots walk and talk? There are two problems. First of all, these robots cannot recognize objects very well. When they walk into a room, they see straight lines, curved lines, shadows. That's all they see. They don't see tables, chairs, tabletops, vases, flowers. They see lines, circles, squares. They don't know what these circles mean. So for them, a picture is just a picture of lines. It doesn't recognize what's inside that picture. And second of all, they don't have common sense. Here's a robot that has the intelligence of a cockroach, so why not make them look like cockroaches, right? These robots do not have common sense. You cannot tell them a joke. You cannot pal with them. You cannot read to them a nursery rhyme. Our most advanced robot cannot understand a children's fairy tale. A children's fairy tale cannot be understood by any of these robots that we have built. However, we do think that emotions are important. We're definitely going to build robots that have emotional contact. Here's the governor of California in a very bad mood. This, of course, is the Terminator series, okay? However, some people think that maybe in 100 years, when they do become intelligent, maybe they'll be dangerous, in which case we may have to shut them off if they become dangerous, or maybe in the next century, we may want to merge with them and become immortal, become half genetically engineered, half cyborg, and you become immortal. These are some science fiction scenarios that people have thought about. Now let's talk about time travel. This is what I do in the sense that in my day job, I work on something called string theory. String theory begins to answer the deepest questions of space and time, such as, what happens if you go backwards in time and meet your teenage mother before you're born? If your teenage mother falls in love with you before you're born, you're in deep doo-doo. And if you think that's bad, let me now tell you the mother of all time travel stories. We physicists study this story. Listen carefully. The year is 1945. A stranger comes in from the darkness carrying a basket with a baby girl. He drops the baby girl off at an orphanage. And the nuns pick her up the next day. They don't know what to call her. So the nuns call this baby girl Jane. And Jane grows up wondering, who is my mother? Who is my father? I was left as a foundling on the doorstep of this orphanage. And then when Jane turns 19, she falls in love. A handsome drifter comes into her life. But you know, it was not meant to be. Jane has a very sad life. She gets pregnant. Her boyfriend, they argue a lot. He stomps off into the darkness, never to be seen again. And it's even worse than this. Jane has to be rushed to the hospital because she's bleeding very rapidly. The doctors deliver a beautiful baby girl, but that very same night, somebody breaks open the window and kidnaps her baby girl. Well, poor Jane is left bleeding, without a baby, almost dying. So the doctors have to perform an emergency operation. They have to change Jane into Jim. Jim wakes up the next day saying, whoa, what a headache. I was left as a foundling on the doorstep of this orphanage, fell in love, he disappears, I'm left pregnant, somebody steals my baby girl, and I'm not even Jane anymore, I'm Jim. Well, Jim gets into barroom fistfights anytime someone says, who are you, Jim? Where'd you come from? Who's your mother, your father, your brother, your sister? Well, one day, poor Jim is stone drunk, once again, at the bottom of a bar. But this time, a bartender comes up to him and says, Jim, wake up. I'm not really a bartender. I'm a time traveler. Come into my machine and let us together find out who is Jim/Jane. So they go back into the past. And Jim is left in the past somewhere. He's disoriented. But then he suddenly meets this beautiful 19-year-old girl. And it's love at first sight. But you know, it was not meant to be. They quarrel, and Jim stomps off into the darkness. But then Jim finds out that his girlfriend is pregnant. And he says, oh my God, I don't want my baby to have the same kinds of problems that I had. I want the best for her. So Jim goes to the hospital, breaks open the window, kidnaps his own precious baby girl, and then goes back into the time machine when they go back, way back into the past until it is 1945. It is a dark and stormy night. Jim comes in from the darkness carrying his precious baby girl that he drops off at an orphanage. The next day, the nuns find the baby girl. They don't know what else to call her, so they call her Jane. And Jane grows up wondering, who is my mother, my father, my brother, my sister? Well, Jim finally says to himself, you know, being a time traveler really made some sense to me. I don't want to be a drunk for the rest of my life. So Jim joins the Time Travelers Corps and has many heroic exploits. Now Jim is an old man. He's an old man about to retire. But he says, you know, I want one last mission in time. So Jim gets permission to go backwards in time, put on a wig and mustache, to impersonate a bartender, to meet a certain ballroom drunk who is stone drunk on the floor once again because somebody asked him, who are you, Jim? Where'd you come from? Who is your mother, your father? Now, for 10 points, who can tell me who is Jim's mother, father, daughter, son, grandfather, granddaughter? She is a family tree unto herself. Can you imagine a family get-together? And Jane says, "You did this to me." And then Jim says, "No, you did that to yourself." Well, is any of that possible? Well, believe it or not, we have studied Einstein's equations, and the answer could be yes. These are wormholes. They are found at the center of black holes. We've now seen, of course, thousands of black holes in outer space, gorgeous photographs taken by the Hubble Space Telescope, but we've never sent a probe inside. If you send a probe inside, perhaps you will see a gateway to another universe. Still controversial. Not every physicist is convinced that we can do this, but the equations say that at the center of the wormhole, there is a looking glass. When a black hole collapses, it doesn't collapse to a dot. A spinning black hole collapses to a ring. A ring is at the center of a spinning black hole. If you pass your hand through the ring, your hand goes through the looking glass into Wonderland. So this is what the equations tell us. And so then the question is it possible to build a machine that can take advantage of this? Well, I'm running a little bit out of time. I'm not going to show you the blueprint of the time machine, but let me go to the next view graph. It'll be on the BBC special. We actually show you what a time machine looks like in that special. But let's move on, because I want to talk about the future, the far future. When we physicists scan the heavens looking for extraterrestrial intelligence, we don't look for little green men. We look for type 1, type 2, and type 3 civilizations. A type 1 civilization is planetary. They control all planetary energy. They control the weather. They control the oceans and hurricanes. That's type 1. Type 2 is stellar. They control the power of a star. Then there's type 3, which is galactic. They control the energy of an entire galaxy, perhaps 100,000 years more advanced than us. And what are we on this scale? We are type 0. We're not even on the radar screen. We get our energy from dead plants, oil and coal. This is type 1. A type 1 civilization is about 100 years more advanced than us. They control the weather, control earthquakes and volcanoes, hurricanes, anything planetary they control. Perhaps they've even mined some of the nearby galaxies. Now, a type 1 civilization is in our future. For example, what is the Internet? The Internet has caused such a big sensation, but what is it? The Internet is the beginning of a type 1 telephone system. That's really all it is. We are privileged to be alive to witness the birth of a type 1 telephone system. And then, what is English? English will be the language of this type 1 civilization, not French. Sorry about that. The European Union is the beginning of a type 1 economy. Why the European Union? Because they're competing with us. We are NAFTA. Huge trade blocs are beginning to represent the type 1 economy. And we can also see the beginning of type 1 culture. You go anywhere in the world today, and teenagers are writhing to rock and roll, blue jeans, rap music, also mass media, high culture, Chanel. These are brands. These are cultural trends that we see everywhere on the planet Earth. But also there are people who don't like this. They instinctively do not want a type 1 civilization because a type 1 civilization is progressive, multicultural, technological, scientific. Who are these people? The terrorists. Terrorists feel more comfortable in a type -1 civilization where they get their energy from rocks. This is type 2. A type 2 civilization can actually harness the sun itself. They can build a shell around the sun to harness all the power of the sun. Type 2 is immortal. These civilizations cannot be destroyed. Nothing known to science can destroy a type 2 civilization. Meteors can be deflected. Ice ages can be avoided. They can even survive the death of their mother sun by going to another sun. Then there's type 3, galactic, like Star Wars. Now, if you are a Star Trek fan, you know that Star Trek is basically a type 2 civilization. The Federation of Planets has colonized a tiny sector of the Milky Way galaxy. They're type 2. However, for you Trekkies out there, who can tell me the name of the type 3 civilization on Star Trek that eats type 2 civilizations like the Federation for breakfast? the Borg. We have some true blood Trekkies out there. This is type 3. They have sent probes throughout the galaxy, self-replicating probes throughout the galaxy. They can even begin to build gigantic atom smashers to open up gateways, holes in space, to perhaps create what we call the false vacuum, otherwise known as a baby universe. Perhaps to create a hole in the fabric of space and time. Now, I gave this talk in London a few years ago, and a little boy comes up to me about the age of 10, and he starts to pull on my pants. Annoying kid. And he says to me, "Professor, you're wrong. There's type 4. And I look down on this kid, and I say to him, "Shut up, kid. Why don't you go play in traffic? There's a nice intersection over there." And he kept tugging and tugging on my pants. And he said, "Professor, you're wrong. There's type 4. And I said to him, "Look, kid, we have planets, stars, and galaxies. Therefore, we only can have 3 types of advanced civilizations, type 1, type 2, type 3. There is no type 4. And then he kept yanking on my pants, and he finally said, "Professor, there is an energy source beyond the galaxy. It is the continuum." Now, for you Trekkies out there, what is the name of the only type 4 civilization on network television? The Q. Very good. We have some true blue Trekkies out there. And if you did not understand what just transpired, get with the program. It's on channel 11. Get with the program. So perhaps in the future, we may be able to drill a hole in the fabric of space and time itself. Perhaps escape into hyperspace, or perhaps even create a baby universe. Just remember that when we talk about civilizations in space, our Earth also radiates. Our Earth radiates radio and television. Surrounding the Earth, there is a sphere, 50 light years in radius, because we've been broadcasting for 50 years. The sphere is expanding at the speed of radio. It contains the finest of our cultural archives, the noblest achievements of the human creative spirit, like I Love Lucy, Leave It to Beaver, and now joined by the immortal classics Beavis and Butthead Part 2 and Dumb and Dumber Part 2. And any star within 50 light years of the Earth will pick up our cultural emissions, and they'll be convinced there's no intelligent life on the Earth. Let me end on one last note. And I spoke at the Einstein Centennial a few years ago in Alexandria, Egypt. And this is my favorite Einstein story. When Einstein was an old man, he was tired of giving the same speech over and over again. So one day, his chauffeur came up to him, and he said, "Professor, I'm really a part-time actor. I've heard your speech so many times I've memorized it. Why don't we switch places? I'll put on a mustache and a wig, and I'll be the great Einstein, and you can take a rest and be my chauffeur." Well, Einstein loved the joke, so the chauffeur put on a mustache and a wig, and he gave the great talks of Albert Einstein. This went very good until one day there was a mathematician in the back who asked a very difficult question. And Einstein thought, "Oh, the joke is up." But then the chauffeur said, "That question is so elementary that even my chauffeur here will answer it for you." Thank you very much.
Impossible. So we have time now for some questions. Anybody? We have 2. Daryl's going to roam over here with a microphone, and so just put your hands up so we can see you.
Sure. Thanks. Great talk. I've heard some ideas that in terms of exploring the cosmos and intelligent civilizations, maybe what might happen is we'll never be visited by anyone else because advanced civilizations will get involved with virtual reality and send robots out, and basically they'll never go anywhere themselves, and they'll just sort of, collapse on their own virtual reality and sort of sit on the couch forever. What do you think about that idea?
We already have that. That's called couch potatoes that sit in front of their TV sets. No, the question is, will intelligent beings in outer space, being so advanced, simply sit back and let robots do all the work, and they just relax and watch videotapes of all their exploits? That is, in fact, the most likely scenario of all scenarios. No civilization, I think, is going to send Captain Kirk and the Enterprise going from planet to planet to planet. Because how many stars are there? There are 100 billion stars in the Milky Way galaxy, and we think maybe half of them have planets. So it's simply inefficient to send Captain Kirk. What is most efficient are these self-replicating von Neumann probes. Self-replicating viruses that land on a moon, make copies of themselves, and then send the videotape back to the home planet, where all the couch potatoes on the home planet can experience the wonders of visiting the Earth. So that is, in fact, mathematically speaking, the most likely form of visitation. But the other question is, well, why don't they make contact with us? Why don't they shake our hands and say, here we are? Well, if you're walking down a country road and you see an anthill, do you go down to the ants and say, I bring you trinkets, I bring you beads, I give you nuclear energy, I give you biotechnology, take them into your leader? Or do you have the strange urge to step on a few of them? My attitude is, let's not make contact with these aliens too quickly. Okay? I have friends of mine who professionally search for intelligent life in the universe. I just had one on my radio show last weekend, in fact. And I told him that I think we should keep our existence a secret until we understand their intentions. Now, of course, in the movies, we all know what they want to do. They want to eat us. You saw that Twilight Zone episode, To Serve Man? Now, To Serve Man was a cookbook. To Serve Man, you know, fried, fricasseed, once over easy. So we don't necessarily want to make contact with them, but to listen in is fine. But the question is, why don't they visit us? I think the most logical answer is the one you mentioned. They'll send robots and videotape us and send the videotapes back home.
Thank you very much. Wonderful information. Winston Churchill once said that in the future, all the empires of the future will be empires of the mind. Do you think in our lifetime we will actually see the ability to have mind over matter?
Well, I think Winston Churchill's prediction is more or less coming to be with the coming of a Type 1 civilization, in the sense that we will have wars, we will have fights, we will have states, but more and more planetary cultures, planetary norms, planetary thinking will become the dominant thinking on the world today. If you were to talk to our grandparents and talk to them about how integrated we are today, they would say, that's ridiculous. I mean, wars, we've always had wars, empires and slaughters and genocide. Our grandparents would be amazed seeing the world today, as messed up as it is today, compared to what it was before World War II, compared to what it was before World War I. Now, you ask a different question, mind over matter. In the book, I do discuss telekinesis, that is, the ability of the mind to control objects. But at the present time, it doesn't seem to conform to the four forces that we see around us, gravity, the nuclear forces, and the electromagnetic force. However, I think in the future, if we can control laptop computers by thinking, and this is already possible now with stroke victims at Brown University, and the computer in turn can control magnets, supermagnets inside objects, we will have the ability to move objects by thinking about it. If we have room temperature superconductors, we don't have them yet, but if we have room temperature superconductors, then we'll have what are called supermagnets. We'll be able to have trains levitating on an invisible magnetic field. We'll have those floating cars like in the Jetsons that everyone wants to get. We'll have them. And once we connect them to the internet and the internet to your mind, you'll be able to move objects with the force of your mind. And we can't do that yet because we don't have room temperature superconductors, but every laboratory on the Earth with the solid state group is trying to find the holy grail of solid state physics, which is room temperature superconductors. Once we have them, you can put on a belt and fly like Superman. Yeah? Oh, the microphone. Where's the microphone?
Hello.
Oh.
Yes, thank you. You said that the internet might be the telephone system of the next generation of civilization.
Yeah.
But if we all have our brains connected directly to the internet, Does that represent maybe a higher level organism, that the internet is just a nervous system of?
Possibly. Some people have thought of the internet as more than just a telephone system, but as perhaps a network where minds can come together. And like I said before, we could already have the first human connected to the internet and surf the internet. What happens if we have lots of people connected to the internet? Already we have a program called SETI at Home. Some of you may be part of it. We take messages coming from outer space from the Arecibo Radio Telescope in Puerto Rico, chop it up, send it out to screensavers, millions of screensavers around the world, and your screensaver at night might be able to pick up a message from an alien civilization in outer space. This is the largest computer program on the planet Earth. It is the first planetary computer program done by millions of laptops, and you could do it too tonight. Just go to SETI at Home, S-E-T-I at Home, and you too could be part of the first software that is truly planetary. But you ask whether or not the brain itself can be connected, and the answer is yes. The first brain was connected 2 years ago to the internet. What does that mean for the future? We don't know. Maybe emergent phenomenon could come out of this. We don't know. This is really at the cutting edge of where we are now with computer-mind interface. Yeah, good to you.
So you said just before that telekinesis, the whole mind over matter thing, has kind of become possible these days. So I think it said that one of the impossible things up there was something like precognition. Now, would it be possible for electrons to be put inside the head that not necessarily control the computer or physical objects, but to be connected to electrodes inside somebody else's mind, which thus could cause a kind of telepathy, and then possible precognition for at least premeditated crime or whatever?
You mean like Minority Report with Tom Cruise?
Yeah, sure.
Okay, let me break that question down. First of all, mind-to-mind connection via a computer. We don't have that yet. We have right now the brain connected to a laptop, laptop connected to the internet. That's all we have at the present time. A direct mind-to-mind hookup won't work because the brain cannot unscramble. The brain can produce waves, but the brain cannot interpret these waves because there was no evolutionary pressure for the brain to understand electromagnetic impulses from another brain. But if I have two brains with a laptop between them, then it's possible that the laptop can act as an interface, decipher our messages, and then send them to another person, and then have direct mind-to-mind interaction. That is something which is possible. It hasn't been done yet. But again, this is still very new, only within the last few years. Now, precognition, actually seeing the future, we don't think is possible. That is a class 3 impossibility. However, in time machines, we have the problem of precognition. In time machines, which we think are possible, how do we resolve the paradox of going backwards in time and shooting your parents before you're born? If you shoot your parents before you're born, how can you be born to go backwards in time to shoot your parents before you're born? The answer is, first of all, Einstein said that time is a river. It can speed up and slow down. We measure this every day with the GPS system. The GPS system would fail unless we recalibrated for Einstein's theory of time. However, the river of time we now believe can have whirlpools and can have forks into two rivers. So when you go backwards in time and meet your teenage mother before you're born, she looks like your teenage mother, she acts like your teenage mother, but she's not your teenage mother. She has all the genes and memories, but you've entered another time stream. Therefore, causality is preserved. There's no precognition. Causality is preserved when you go backwards in time because you've interacted with somebody else's mother. Your mother gave birth to you. That cannot be rewritten. But anyway, I have a whole chapter on precognition. Precognition, as we see in the movies, is not possible, but certain forms of precognition aided by machines may be possible. You had a question right here, right? Can we have this person's question? He was waiting a long time.
I have a two-part question dealing with time travel. There's a professor in Yukon who believes if you took a laser beam and you spin it around, you took several of these, like a cylinder that you were talking about before with invisibility, you could bend space, and the faster it went, you can actually bend time itself.
Yeah, there is a physicist who says that. However, that's not what most physicists believe.
So that's just his opinion.
That's his opinion, right?
Okay.
It is not the opinion of everybody else. He's the only one who holds that opinion.
Gotcha.
And the reason is very simple. Einstein says that the more matter you put into space, the more disruption you have. There's a one-to-one correspondence. It's like throwing a rock into a pond. When you throw a rock into the pond, the bigger the rock, the bigger the splash. That splash is a distortion of space and time, the surface of the pond. That's what we want to rip. We actually want to rip the surface of the pond. Therefore, you have to put a pretty heavy rock to get that rip. That rock is a black hole. It's a very simple calculation. I give it to my students. Calculate the energy necessary to rip the fabric of space and time. Laser beams can't do it. You can calculate the energy. It's the lasers. You're off by about 10 to the 19th. So it's not possible, the way he says.
So the way
he's the only one who holds to that theory.
My second part of the question has to do with time travel. The CERN Institute is developing the Large Hadron Collider.
Yeah, it's going to be turned on in a few weeks now.
Right. Some have speculated that that might hold the key to time travel. What's your opinion on that, or what's your just educated?
Well, there are lots of mythologies based around the Large Hadron Collider, and I have to admit that I participated in that. I had lunch once with the Science Fiction Channel on one of their advisory boards. I mentioned years ago that the Large Hadron Collider might produce mini black holes. These are harmless. They hit the Earth all the time, we think. Nothing happens to the Earth. The energy of these mini black holes wouldn't even light up a light bulb. However, a light bulb went off on top of the producer from the Science Fiction Channel. And they produced a Science Fiction Channel special. Atom Smasher eats up the Earth. Okay? Well, unfortunately, some people didn't get it. They thought the Science Fiction Channel special that I casually mentioned to the producer was real. And now they filed a lawsuit in Hawaii, a federal lawsuit in federal court trying to prevent the opening up the Large Hadron Collider. Let me say right now, the Large Hadron Collider is not going to eat up the Earth. The energy of these teensy-weensy subatomic black holes wouldn't even light up a light bulb. The energy from outer space is much greater than the energy we can produce with the Large Hadron Collider. And we're not going to be able to build a time machine with that machine. What we hope to get from that machine are sparticles. Sparticles are superparticles, particles that we've never seen before. We think that we represent the lowest vibration of a vibrating string. Inside our body, we don't have dots that are electrons. These dots are strings, rubber bands, we think. When you change the frequency of the rubber band, the electron turns into a neutrino. When you change the frequency again, it turns into a quark. You change it thousands of times, it turns into thousands of different particles. When I got my PhD from the University of California at Berkeley, I had to memorize the names of all these goddamn subatomic particles. Thousands of particles. Tau meso, leptons, cascade particles, tau plus, tau minus, tau zero. Thousands of these particles. In fact, J. Robert Oppenheimer, father of the atomic bomb, was so disgusted that we were finding so many particles whenever we smashed a proton apart that he made the formal announcement, quote, "The Nobel Prize in Physics should go to the physicist who does not discover a new particle this year." In the future, I would just hope that a PhD candidate at Berkeley would simply say, "string theory," and get their PhD. All those thousands of particles, believe it or not, are nothing but the lowest vibration of a rubber band. The next higher vibration we haven't seen yet, they are the sparticles, which we hope to produce outside Geneva, Switzerland. The machine is 17 miles in circumference, the biggest machine of science ever created. So let me just answer one last question, then we'll wind up. Some people ask me, well, what about our machine? How come it's a European machine? What about the red, white, and blue? Well, we had our chance. We blew it. In 1993, the Super Collider was being debated by the United States Congress. It was to be much bigger, about twice as big as this puny machine in Geneva, Switzerland. It was to be built outside Dallas, Texas. Near the last day of hearings, we physicists were being interrogated by Congress. Congress gave us $1 billion to dig up the hole. And then they were wondering, should we cancel it? They asked a question. One congressman said, quote, "Will we find God with this machine? If so, I will vote for it," unquote. Now, what did that poor physicist say? I paraphrase. He said something like, No. He said, we will find the Higgs boson. All the jaws hit the floor on the United States Congress. $11 billion for another god-darn subatomic particle. The next day they took the vote, and the machine was canceled. For the last 15 years, we physicists have been replaying that scene over and over in our mind. What should we have said when the congressman said, will you find God with this machine? Well, I don't know, but I would have said this, and I'd like to close on this note and then sign your books. I would have said, God, by whatever signs or symbols you ascribe to the deity, this machine will take us as close as humanly possible to his or her greatest creation, Genesis. This is a Genesis machine. Its purpose is to recreate on a microscopic scale the greatest creation of all, the creation of the universe. Instead, we said Higgs boson. What can I say? Thank you very much. You've been a great audience.